Good afternoon. My name is Joe Rubel, and I'm a system engineer with professional services here in Redlands, California. Joining me today as co-presenter is Melanie Harlow, who is a product engineer with Image Server team, also in Redlands. We'd like to welcome you all to today's live training seminar. During this seminar, we'll be introducing ArcGIS Image Server 9.2, a new ESRI product available with the current release. This product focuses on imagery and offers a new approach to providing imagery for use with GIS and other applications. We'll introduce the concept of image services, what they are and how they work. We'll talk about creating and managing image services, discussing many of the options that are available to imagery providers. We'll also talk about using image services, how to connect to them, what properties they have, and how the properties can be adjusted. The seminar is divided into 3 presentations, each followed by a short demonstration and a question and answer period. The first part of the presentation discusses the use of imagery in GIS and shows how ArcGIS Image Server 9.2 solves problems associated with using imagery. Imagery plays an important role in GIS and mapping applications. Most of us cannot imagine using a GIS without the capability of showing georeferenced imagery as a backdrop. Georeferenced imagery is critical, both as a source of new data and as a way of validating existing data. Features that are visible in recent images may not exist in current maps, requiring updates to the geographic data sets. This situation also highlights the need for images that are up to date. Imagery has become increasingly easy to collect, so there's much more imagery available than ever before. Satellites can now collect imagery very quickly over any place on Earth, and aerial survey techniques have been improving as well. Because of this ease of collection and the time value of new images, the demand for imagery is increasing. At the same time, increased resolutions means larger file sizes are involved. Keeping up with this demand is causing lots of problems for imagery providers. The current approach for imagery providers involves collecting and cataloging the images, then making the catalog available to their customers so they can pick the images they need. Then there's usually some pre-processing required. For instance, the desired product may be in a different map projection and have different dynamic range than the original image. Also, if the client's area of interest is larger than an individual image, several images must be combined into a tiled mosaic. Then the final product is copied to media and sent to the customer. The result of all this processing is multiple copies of the original images, and with each processing step, the imagery is degraded a bit. The customer might have to store and work with large files that do not necessarily match the contents of the original image data, and their images never change. Another issue imagery consumers want to overcome is the long time intervals between when imagery is collected and when it's available to the end user. In response to these problems, ESRI is introducing ArcGIS Image Server 9.2. This product offers a solution to these problems, providing a new paradigm for using imagery. This approach is based on a server-client architecture. Instead of sending customers image files, an agency that provides imagery can now use Image Server 9.2. The host publishes the image services and sends their clients everything they need to connect to the image services across a local area network or across the web. An image server listens for requests from a client, and a client application issues a request to connect to the image server. In response to which, Image Server returns a list of available image services. After selecting an image service, the client requests the properties of that image service, in response to which the image server returns those properties. These properties are displayed in a properties dialog and can be modified by the client. The client may then choose to modify and set these properties in preparation for requesting an image of a particular size and location. Only when this image request is received does Image Server access the imagery, compose, and return the virtual image to the client. For most image requests, the return image is small, so it can be delivered very quickly, allowing the viewer to zoom and roam around normally. Compression can also be used to keep the transferred files small. This cycle of the client requesting images and the image server returning images repeats as the user moves around the image area. An important aspect of this architecture is that the server host performs all the work and eases the burden on the client application. This approach results in many advantages. One extremely important aspect of Image Server is the fact that it dramatically reduces the time interval between when new imagery is collected and when it is available to the end user. This time interval, which can be weeks for large projects, can be reduced to a matter of hours with Image Server. As new imagery becomes available, the image services can be updated instantly. Any image request issued after the updates has access to the new updated imagery. Image services are accessible via a local area network and also over the World Wide Web, providing many ways for clients to add imagery to their applications. Image Server can also control access to sensitive imagery by enforcing the use of usernames and passwords before access is granted. Another set of advantages stems from the fact that Image Server host performs all the processing on the fly. That is to say, all geometric and radiometric corrections are done while the image service is being fulfilled. Because of this, both thick clients, like ArcGIS Desktop, and thin clients, like web browsers that do not have GIS capabilities, can request and receive imagery from Image Server. This also means that the imagery can be kept in its native format, as it was provided by the image vendor, without the need for maintaining additional copies. This imagery can be stored as files or within a DBMS. Processing images ahead of time is now unnecessary, since all processing happens as it is needed and only on the pixels in the requested area. And the resulting image is resampled only once, since it accesses the original file. This ensures the highest image quality. Another benefit of on-the-fly processing is that multiple products can be produced from a single source image. For example, a Landsat scene can support image services that provide true color images, false infrared images, or a vegetation index map. What exactly are ArcGIS image services? It's not just a collection of image files. Instead, it's a collection of the information about the image files and all the processing steps needed to fulfill any image request. This information is stored in a format that allows quick access by Image Server, so any image request can be provided efficiently. Image services are published by name that can describe their geographic location and/or theme. For instance, Amberg Ortho or Modus 12-month. These services also include metadata about the images, such as when they were collected and what type of sensor. This information helps the end user decide if this is the best imagery for their needs. Image Server supports all ArcGIS supported raster formats, including TIFF, GeoTIFF, NITF, JPEG, and many others. Image Server provides one contiguous view of a service area by creating a virtual mosaic. The image service seems more like a single image rather than a lot of different files. As you navigate around the image service, a new image is created every time based on the current mosaic methods. And the service overviews ensure that even when zoomed out to low pixel resolutions, and image pixels are accessed efficiently and served up quickly. Image Server returns a virtual image for each request. Each new image request results in an image newly assembled from the source file using the latest information, then sent to the client. Let's see how these image services work. For this demonstration, we're going to consider ourselves a typical GIS user with ArcMap. We'll use the ArcMap 9.2 image server client to add an image service to our map. We'll navigate around the map, change some properties, and then save part of that image. First, I'm going to add in the image server client tools, which are available to any ArcMap user, whether image server is installed on your machine or not. These commands allow us to add an image service or to change the viewpoint. So these client programs are all I'll need to access image services. When we click the Add Image Service button, we can navigate to the image we've been told about. In this case, it's Hamburg City, Germany. And we'll load it into our map. We see an overview of our city area that's composed of 12 source images that are from an aerial survey that overlap. Let's look at some of the properties of this. We're using a mosaic method of closest to viewpoint that takes advantage of the fact that the photographs have a lot of overlap. But currently, we're not using any compression. And because of that, if we look at some of the metadata, particularly that about the image that was returned, we can see that it's over 400 kilobytes. But if we were connected to a slow bandwidth, we may want that to be smaller. So we can choose a compression of about 80% with JPEG. Then after this is applied, and we move our imagery, requesting a new service in the meantime. Now, if we look back at the size of the file that was sent, we'll see that it's much smaller. So this can be advantageous if you happen to be working over a small bandwidth. The image server client knows to load this image service as a raster layer in ArcMap. So we have access to all the tools that we could use in GIS. We can zoom in and pan. Each new request is getting a new image from our image service. I'm going to take advantage of the fact that because of the overlap, we can see many places in this image from several places to illustrate the viewpoint tool. Currently, we appear to be looking from the southeast, and we can't see certain features on the other sides of these buildings. If we choose a viewpoint from the northwest or the northeast, we can apply that and now see the features that were obscured before. This is an illustration of the fact that even though several images overlap for this particular area, Image Server can choose which one is the most appropriate based on the criteria that you set. Finally, we may want to save this part of the image for working with locally or sending to a colleague. We can use the export option to save all or some of our image service. In this case, we're just going to save the current extent, and I'll give it a file name. In which to save the imagery. What we've seen in this demonstration is the ArcMap clients, these two tools that allow us to connect to image services and use the viewpoint tool from within ArcMap, even though we didn't have the image server installed. We moved around the image and we changed some of the properties so that we could get just the image we wanted. To review what we covered in this first section, imagery is very important for GIS and mapping applications. but issues associated with the current methods of providing imagery can be overcome using image server and image services. The ArcMap 9.2 image server client allows connecting to image services over the web or local area network, treating the image service as a raster layer in ArcMap. Let's answer some of your questions at this point. Melanie?
Thanks, Joe. Got a few questions here. One is from Teresa, and she asks, can services from image server be used with ArcGIS server or ArcIMS? And the question is yes. What you do there is you create a map document in ArcMap. You add the image service layer into that map document, and you save the map document. And then you publish that map document with ArcGIS server. There are install notes, and there is a topic in the web help that you can look at about this. You need to make sure that you have the client installed on the server, and I think you also need .NET there first. Then we have another question from Anne. She asks if we can serve up elevation data, and the answer is yes. We can serve up DEM data that's stored as a raster data set. We don't handle vector data like a TIN or a terrain that's derived from LiDAR data. What you would do in that case is convert that data to a raster data set, and then you could read it from image server. I have another question here from Raymond. He's wondering if we can plot high quality plots from image server services that are really large. The question is, or the answer to that question is yes. There's several different settings that you're going to have to alter to make sure that you can pull enough pixels from your image service, because we do sort of put a limit on that by default, just so people can't access too much data at one time. There's actually a pretty detailed topic in the web help titled Printing Layouts Containing an Image Service, which should specifically cover all the information you'll need and tell you where to go and what considerations to take, how to increase that default value. Usually we have a default of 3,000 by 3,000 pixels. We often recommend people, if they know there's going to be some big calls, then bump it up to 10,000. Sometimes some people may need to bump that up a bit higher. We have another question from Laura, who's asking if image server can do reprojections. Absolutely. Image server taps into the same PRJ files that you use in ArcGIS, so we're using the same mathematics. The one thing about image server is the service itself can have one projection, such as a world Mercator, and then the data, the raster data that's being added to that image service can be in completely different projections. Some could be in UTM, some could be in state plane. They don't all have to be in the same projection, but when they're mosaic together and they're sent to the client, they'll be sent in that image service projection, the world Mercator. And then the clients can change that projection. Our ArcMap clients, the projection change is done in the data frame, but our clients in AutoCAD or even the standalone viewer that we have, you can go in and choose a PRJ file and reproject that way. And I'll let you get back to Joe.
Thanks, Melanie. This portion of the seminar discusses creating and managing image services. We'll do this from the viewpoint of somebody who is providing image services. ArcGIS Image Server 9.2 consists of several components that work together to provide image services to client. Working from the bottom of this diagram towards the top, let's look at the components of this architecture. First off, the lowest tier represents imagery, or other raster data, such as elevation models, which reside on disk either in a file system or in a database. The service editor is used to create or modify the image services, which are stored as image service definitions, represented here with these green circles. These definitions contain information about each image in the image service and all processing steps that will be required. You can generate several image services definitions for a single image source to represent the data in different ways and with different processing. The service providers are the workhorses of the system, reading the image service definitions and generating the output for each client request. This component can be installed on multiple machines to support many client requests. The image server itself serves as a single point of contact for the clients and acts as a request broker. When a request is received from a client, Image Server determines which service provider is the best to satisfy that request based on how busy they are. This allows the demand for image services to be balanced among multiple service providers. The server manager manages all these: the image server, the service providers, and the image services. It is used to start and stop each component and to publish the image services. This architecture allows the system to be easily scaled out. So when there is more demand for image services, service providers and host machines can be added to the configuration to handle the increased demand. The presence of many service providers makes the system fault tolerant and provides a failover path that allows clients to be served even if some of the host machines are unavailable. Service Editor is used in many contexts. It can be used to create new image services and define their properties. It's also used to add new imagery to an image service or to remove imagery that's no longer needed. It can be used to define any processing that has to be applied to all the images or to any particular image. It can also be used to optimize and preview an image service. This component is accessed as a toolbar in ArcMap. There are several categories for which an image service author can enter information. They can add metadata about the image service and the individual images. This information is used by the end user to help determine if this is the best image service for them, and to publish information such as when the imagery was collected, which agency owns the data, what processing has been done, the accuracy of the imagery, and much more. It also allows a definition of what processing steps will be applied and in which order. There are many geometric corrections and image processing algorithms that can be applied to an image service. These include simple processes such as scaling image values from 11-bit to 8 bits, applying various filters, or changing the band order. It can also include complex processing, such as orthocorrection, that is, removing the effects of terrain so an image will correctly align with a map, and pan sharpening, a technique to combine low-resolution color imagery with high-resolution grayscale values to create a simulated high-resolution color image. Additionally, the service can be defined with many client-controllable properties. These are the properties that are returned to the client and can be modified. Once an image service's properties have been defined, Image Server creates any service overviews that are needed and compiles all the information into a binary file that the service provider can use to serve the images. An administrator uses the Server Manager application to manage the image server, the service providers, and the image services. There's tools in this application that allow the administrator to configure an image server and the service providers, to view the status of the image server components, to start or stop the image servers, service providers, or image services, to synchronize a modified image service, to review or export log files, and to manage security. Due to an open system architecture, ArcGIS Image Server is customizable. Image services are based on XML files. Therefore, many of the files that define an image service are stored in that format, which has a well-known structure and is accessible by many software products. For instance, when an image is normally added to an image service, certain metadata fields are extracted from the header of that image. However, you may want to include other information that's stored with the image that is not currently captured by Image Server. The system architecture allows you to create a reader to automatically extract the new information from the image and store it in the XML file that corresponds to that image. Most of the processing steps done by Image Server can be accessed via a command line interface. This means it is possible to create scripts to take advantage of embedded Image Server commands, as well as custom code that you might have to create image services or modify the properties of an existing image service. This can dramatically reduce the work needed to create and maintain image services, as well as to streamline the processes. Similarly, there may be certain image formats that you use that are not currently supported by Image Server. You can easily add new raster type to the system by following the template provided with the software. Once added, your new raster type can be used just like the existing raster types. It's also possible to create new Image Server clients to support additional programs. We'll talk more about Image Server clients in the next section. For this demonstration, we're going to take a behind-the-scenes look at how a service provider uses Image Server to publish image services. We'll load the file that defines the image service we saw in the previous demonstration and use the image service editor to change some of its settings. Afterwards, we'll use a server manager to update the image service. So first I'll unload our previous connection. And now I'm going to load the file that defines the image service. This is different than the imagery. We're not getting the pixel values, but we're getting information about all the images that comprise this image service. I'm also going to activate the image service editor, which provides the tools we'll be using to access this image service definition. There's tools here to look at the service properties or the service table or the properties of individual rasters. There's also a set of menus that allows you to define a new image service using a wizard interface or to do other advanced topics. What we're going to do at the moment is add a preview to our image so that we can see the effect of any change we make instantly. So there's our preview displayed. First, we're going to look at a service table. This contains an entry for every image on our image service. First, we have the 12 original source images, and then 4 service overviews that were created to handle services where you have a coarser pixel resolution. If we look at any individual entry, we can see the footprint of that image in the corrected image, and we can notice overlap between successive imagery. Also, we can note that service overviews have a larger footprint. This table contains references to the image files as well as to the XML file that describes the processing that goes with each image. Now let's look at the properties of this image service. We want to change a couple just to show that we can, and there's too many fields to really look at many, but I'll concentrate on the metadata tab, where I wanted to change the name to Hamburg City Center based on my client feedback. I'll go ahead and apply this change. I've also heard that they thought the imagery was too red. So I'm going to go back to my stretching process and adjust one of the settings. I do see that the red curve is a little high. Let me move this down here. So I'm going to change the setting back to 1.0 for the red gamma and apply these changes. Now, the next image request I make by moving the service will be an image that has the red less emphasized, and also will have a different title. Now that I've made those changes, I'm going to compile them so they can be saved and accessed by the service providers. We get a couple of messages giving us some information about the progress and if there was any problems. When this is finished, we'll use a server manager to update this service so that any new requests will access the new data. Actually, it's the original data with the new processing steps. So now our service is compiled, and we're going to bring up the server manager to identify our service. We'll stop it, start it, and then we'll do a synchronize to make sure everything is in sync. From this point on, all new service requests for that image service will get the new processing steps. So let's review what we did in the demonstration. We used the image server toolbar to load a service definition, look at the service table to get some insights into how those images are defined. We used a service editor to modify some of the properties. Finally, we compiled and updated our image service. We covered a lot of ground in this section, and I think you have a better idea of how image server works to define image services. We looked at a few components like the image service editor and the server manager, and we talked about how image server allows customization and automation. Time again for more of your questions. Melanie?
Thanks, Joe. I have a couple questions here. One from Christy, who wants to know how to install the product, and another from Meg, who asks if there's different licensing levels. Image server just has one license level. It does have two extensions. One is specific to a seam line, and another one is for the orthorectification. And although a lot of these demos are done using ArcInfo, it doesn't matter if you have ArcView, ArcEditor, or ArcInfo. You can edit the service, and you can access the service as a client. Now, to install, there's merely one setup, and it will install all the different components either on one machine or on the separate machines. And then we have separate client installs for each of the 4 clients. And speaking of clients, we also have a couple questions about that. What are the export formats? It's TIFF, JPEG, JPEG 2000, and PNG. And the file is in the same spatial reference as you're viewing it in. When it's exported, you have the option of exporting it with a TIFF world file. And people are wondering if they get all the different layers. It's one single file, and it's exported typically at the resolution that you're viewing, but you can change your extent and the pixel parameters a little bit. And yes, the export size can also be limited. That's set up by the administrator so that they can make sure that nobody's downloading their entire data set if they don't want that. We also have a bunch of questions about ArcSDE. So what we generally tell people is there's a couple of things you have to think about. We're not telling you to replace ArcSDE, and you can certainly use the two together. So for one thing, if your data is stored in ArcSDE, we're not suggesting that you move it out of SDE. But depending on what you use your data for, this is just another option for you to consider in the future if you're going to continue putting your new data into ArcSDE or if you're just going to store it in a sort of file-based structure out there. Also, if you need to access the raw pixels with SDE or through SDE, then SDE is the answer. If it's not the raw pixel values that you're interested in, you're really just interested in the image for visual analysis, you can certainly serve the data out through Image Server. In our future releases, clients will actually be able to access the pixel values. Another question is if database administration capabilities or security are vital to your organization. If so, leave it in a database. Our image server is not a database, and it doesn't have those same capabilities. We use what's available in the Windows operating system. If your ArcSDE data is stored as one large mosaic, then it's hard to say if Image Server is going to be faster for you than ArcSDE. It depends again on who your people are. If they're using ArcGIS, then it's going to be comparable. But if your users are also using AutoCAD, then you're probably going to need Image Server to get that data to them. If your data is stored in a raster catalog in SDE, we can't at this time serve raster catalogs out as image services. And if your SDE data is stored in a lot of separate files, then Image Server is definitely a great answer for you. You can serve out your data from SDE, and Image Server will basically serve that data out as one single mosaic file. Also, you can add different data to that service in addition to the SDE layers. So if you've got some file-based data sets located somewhere else, it can all go out as one image service. I'm going to let you go back to Joe for some more.
Thanks, Melanie. In this last section, we'll talk about using image services and about image server clients, the software layer between image server and applications. An ArcGIS image server client is a software layer that acts as a translator between ArcGIS image server and the client applications. As such, it knows how to speak both languages, the requests that are sent to image server and the actions to be taken by the application in response to the answers to those requests. The image server clients are an extension of each particular application, so they can interact directly with that application. For example, the ArcMap client we used earlier contained 2 new commands in ArcMap, and it knew how to add our new data as a raster layer. And these image server clients, either the existing ones or any new ones, are freely distributable to any customer. If you publish an image service, you can send the image server client software to your customers, along with the information about how to connect to those services. There are 2 kinds of image server clients. First, there are direct clients that use an RPC, or remote procedure call protocol. These include image server clients for ArcGIS desktop versions 9.1 and 9.2, including ArcEngine. The image server viewer, a standalone application that allows quick access to image services. The code for this is provided in the SDK in case you want to develop your own viewer. Also, a console client that allows access to image services via command line. And third-party CAD and mapping applications like AutoCAD and MicroStation. Another kind of connection is used for web clients, which use the HTTP convention. This kind of connection is facilitated via ArcIMS and ArcGIS Server. ArcGIS Server can also be used to provide support for other web communications conventions, including ArcGIS Explorer, which uses a global interface, OGC WMS, which is a web-based map service defined by the OpenGIS Consortium, KML, used by some internet mapping services, and SOAP. New image server clients can be created to support other GIS and mapping applications. An image server client program implements the image service interfaces. These interfaces are a common way for object-oriented programs to connect to an object and interact with it. The interfaces are contained in an open API, or Applications Programmers Interface, that's available to any developer. There are also many code samples written in various programming languages for existing image server clients that are freely available. By following the examples of these sample programs, a programmer can create an image server client that can communicate with their local application. The software interface includes dialogues for selecting image services, for examining and updating properties of the image services, and for exporting portions of an image service to a file. We've seen some of these already, and we'll see them again using the image server viewer. So finally, from both the user standpoint and from the standpoint of somebody providing image services, we can say that image services are very easy to use. Once you've been granted access to an image server, you can select your image service by a descriptive name instead of having to navigate through lots of files with cryptic file names. The best imagery is always available to you, whether it's the most recent imagery or it might be better based on some other criteria. Most image services have properties that can be specified by the client, so you get just the image you need. You do not need to store lots of imagery locally, so disk storage is no longer a big issue for the end user. And all the processing is done on the host, so there's no additional drain on your computing resources. Let's take a look at how one of these clients works. We're going to use the image server viewer, which is a standalone viewer. It's a thin client in that it has no GIS capabilities per se. And the code for this is freely available, so this can be used as a basis for writing your own viewers. What it does encapsulate for their open command is our now familiar dialog for adding image services. I want to load the Amberg ortho again, first to show that our change to make it Amberg City Center has taken effect, and also to show that now our imagery has lost our reddish tint. All this shows is that the changes that we made earlier have taken effect for this image service. I'm going to close this now and load a different service. This is based on a satellite view of the world with 12 images, one for each month of the year. Because this is a time sequence set of images, this can allow us to do various effects. The first property I want to change of this is to make it look more like a map that I'm used to. So I'm going to change the spatial reference system to be a geographic coordinate system. So here we've resampled the data that came from our image service into something that we're more familiar with. I'm going to zoom into an area that I know will show some change. And what we'll do is we'll look at the properties of the service and see how the mosaic method is determining which image is shown on top. So if we look at the properties of the service, now we see our sampling method, or our mosaic method, is by attribute, rather than by closest to viewpoint or closest to center, as we saw earlier. It's based on the field called month, and our current value is 6, meaning that we're seeing the image from June. If I change this month to 12, and accept this change, now our new method is showing the image from December. So if you were creating an image service application that was based on this, and you added a slider control to this image, you could potentially link the slider control to which month is being served. We've been doing this manually, but you could do it programmatically. so that your slider bar could give you an animation sequence or allow you to perform change detection. In this demonstration, we saw that a thin client without any JS capability can take advantage of image server client interface to add imagery to their application using image services. To recap what we covered in this section, we showed many of the existing image server clients, and we talked about how newer image server clients can be created to work with your applications. And we pointed out some of the advantages of using image services from a user's point of view. I think we have time for a few more questions. Melanie?
Thanks, Joe. I have a question here from Cara. Is there an input file size limit? No, there isn't. Of course, your file size is often limited by the file format itself. But, you know, please be smart here. A 1 terabyte file would probably take a long time to access, and which would slow down the speed at which a service would be accessed by a client. So I certainly wouldn't recommend that. And there's also no limit to the number of images in a service. That limit, of course, is based on your hardware configuration. I have a couple questions about the kinds of data you can put into a service. We take in a lot of different formats: JPEG, TIFF, Mr. SID. We also have things like the TIFF files that are output with Landsat when you order that. I think QuickBird also can give a TIFF format. In those cases, we also read the metadata files that come with those data sets. And also in an image service, you can have many different kinds of data. So you can have your ortho photos, you can have some satellite data, you can have some DEM data, you can have things at different resolutions. And there's different settings that the person setting up that service can make so that when you're zoomed in at a certain level, you'll see the imagery they want you to see. So if you're zoomed in at a high resolution, you get the best imagery. If you zoom out, then you maybe get the lower resolution imagery. But as a client, you always have the access to any of those images within your area of interest. You can make different selections based on a mosaic method. We have something also called a lock raster that allows you to select and view one image at a time. So if you have lots of overlap, say you have some historic data and some recent data, you can quickly look between the two. Also, the fact that you're not physically mosaicing your data together, they stay all in their original formats. We just access the data as we need it. You're never losing any of the information because there is some overlap. Let's see, we've got a few more questions here. Oh, can ArcGIS server and image server be run on the same machine? Yes. We have an optimization article that's soon going to be published on the web. Talks a lot about optimizing your speed, making sure that you're using the file formats. Some are better than others. When you add certain processes, speed can change a little bit too. We do not recommend that you run your mail server and your image server on the same machine, just because it's, of course, going to take up some time. Image server is not, its speed isn't necessarily affected by RAM. It's basically affected by the speed of your CPU. So you want to make sure that you have a fast computer for access. We have one more question here. What really is the difference in the server and the client? Image server, as you saw earlier, is a bunch of different components. It's one main application called ArcGIS Image Server, but there's a server manager, there's the service provider, which is the workhorse, there's the clients, they're direct connect clients using TCP/IP, and then there's the server application. I think that's it for the afternoon. Send you back to Joe.
Okay, it looks like we're out of time. Before I go, I'd like to point a few resources to you. There's a website for ArcGIS Image Server. There's a lot of information available in the desktop help. There's some online articles in ArcNews, and an ArcGIS Image Server forum where you can post your questions and have them answered by the user community and by the experts. You can also see questions and answers from other users. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of the ESRI, I'd like to thank you for attending.